where should we start? Hold on a sec. I'm waiting to make sure I'm live. Testing, testing. Are you live? Go live. Go live. Let's see. Here we go. Come on. I think we're... Hello.
Testing, testing. Are you live?
R.I.P.
Go live.
Okay.
Go live. Let's see. Here we go. Come on.
Okay, so first thing I want to talk about is TOR. I'm a mental patient, and there are monitors, and the FBI watches, and the CIA watches, and all my internet is about me. And here we have some TOR. Somebody thinks it's about SPD is my little brother, Sean Paul Davis. So we are going to explain to the nigger what tongues is. Okay, so there is a x80. Let's go ahead and do it this way. Read timestamp count. Read timestamp count. Move. It's in AX and DX. So what we want to do is shift right RDX 32 and how about move how about, this is kind of ugly, but how about move RAX EAX. Let move I don't know if that's going to work. And add RAX RDX return. Okay. Let's call get timestamp count, and then let's I equals get RAX percent comedy. Let's see this. Okay, I have a 1 operand and a 2 operand. And this, I guess we want 2 operand. That doesn't make, that's not what it is. Shit, is it? That's not what it is. Shift left. First of all, what am I doing? Okay, son of a bitch. Is it? It's shift left, isn't it? I've used a lot of, I know it's shift left. Okay. That takes immediate. Oh, it's the previous one. The error reporting is off. Let's just move EAX. Okay, so get char. Okay, so here's what, let's unassemble so you get to see what it is. What we can do, just to show off, we can stick this code right here. We can say unassemble function main. So it calls getChar, calls read timestamp count. This is, if it's a 3 gigahertz processor, this is 3 gigahertz. This clear, okay, this, let me explain this. The clock cycles are in EDX, EAX. That's not convenient. So clear high 32-bit. Shift left. Okay. So let's just show that. Okay, so see how that works? Isn't that beautiful? Okay, so now every time I press the this is going by 3 gigahertz. 1, 1000, 2, 1000, 3, 1000, 4, 1000, 5, 1000, 6, 1000. You see how it's 3 gigahertz? Okay. And now let's pick a line number out of the Bible. Let's pick a word. Okay. So U8 star, U8 words, star words. Find words. 20 words. Words. Okay. I don't know if I want to do this. Okay, and no. Okay. Okay, so let's say okay. So let's explain something. In the Bible, they speak in tongues. What they want is for a spirit to puppet them and make them Pinocchio. They want the spirit to make them Pinocchio. Well, that's pretty, that takes some, what you should do is speak English words without controlling what you're saying. Like if you make a list of words, the first word that pops into your head, that's beginning to be a spirit. Don't say it if it's not English, because it's not going to help anything. So only say English words. So what we're going to do is I modulo, oops, I modulo num words. Okay. Rich Pope, money, smart, dumb, sell, Obama, love man, Terry, hate, run, smart man, run. Okay, so, hold on. So let's go ahead and let's print I. Comedy. Let's say oops. Oops. Okay. So you can add words to your list. Let's kick it up to 40. And the trick is you have to hold up your end of the conversation. It's a covenant that you do an offering. Sing. I'm just going to print random words. Okay, so I did okay. What? 1, 2, 3, 4, 5, 6, 7. We need one more. God said no weights. That means no statistical weights. Okay. Who are you going to vote for Trump, Mr. God? I should write it. Oh yeah, I don't know what to do it. What? Hold on. Damn it. Why didn't I do this sooner? Okay, hold on. Okay. You don't need to. Okay, I just want to do that. Okay, so let's review our program. We read the clock floats around in, it's not even constant, it's based on temperature. So let's put some more words. Let's do 60. What's some good words? Linux, Windows, TempleOS, programming, physics, girl, man, top, FBI, CIA. What? Oh. FBI, CIA, priest. Let's see. Drink. Did I already do dance? I don't remember. Okay. Let's see. How about? Ouch. Great. Okay, 1, 2. We're doing. Let's see. How about what I'm doing right now? Just listing words. I think that can be tongues. If you do it fluidly enough, just rattle off as many words as you can off the top of your head, and don't try and control them. I think that'll do tongues. It's revealing, obviously, if you reveal your thought processes. But anyway. Another one. Immigrant. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. What do we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. 14 times 5. What is it? That's not right. What is 4, 13? 12 times 5. Okay. Okay, so you have to hold up your end of the conversation or God won't talk. It's a covenant. Just doing these words is an offering. Okay, what do we? I just did 1, 2. I gotta do 2 more. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, programmer, engineer, I already said programmer. What we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There we go. Okay. 16. 1, 2, 3, 4. 1, 2, 3, 4, 5. 2, 3, 4. Let's see. God likes stained glass windows. Okay, so we do not have TOR. The retard nigger who is watching me does not understand the concept of God. So the retard nigger thinks that I am a lawbreaker and that he is superior to me. In actual fact, I'm fucking Moses and you're gonna suck my... Anyway, fucking nigger. I'm fucking Moses, nigger. Isn't that right, Mr. God? Okay, so the doctor does not know what a random number is. The doctor is a nigger. So what we have here is the CIA confusing the poor little citizens. They're saying source code instead of a wheel. Now, I very carefully explained that everything is just in time in TempleOS. When I hit F5, it doesn't make an executable file, it doesn't make an object file. What it does is it puts code right into memory on a symbol function. Okay, there's a symbol table on it right there. There's the code. It doesn't put it onto an object file. It doesn't put it in an object file. It doesn't put it on in an executable file. It puts it right into memory really fast because I'm the smartest programmer on earth. I was chosen to make God's temple. I made a 20,000 line compiler and I made everything else with divine intellect. It was the, you see how I'm puppeted. You see, do you see this? Is it beginning to make sense? You see how I'm puppeted. Once you understand that I'm puppeted, you begin to understand the inspired word of God. Okay? God puppets big and small. Okay? He controls everything. And the CIA could be snuffed. They could be snuffed. If God had a whim, he could snuff the CIA. So right now they're trying to confuse people. There's a let's go over here and look at Reddit. An interactive photography page for the understanding of the relationship between f-stop, ISO, and shutter speed. Okay, ISO, as in ISO file. OSCD.ISO. You see how they're trying to confuse people? That's what the CIA does. They are a force for darkness and the dark ages and confusion and ignorance. They want ignorance. The CIA wants ignorance. They want really stupid cattle. I don't know why they get their jollies herding dumbass cattle, but the CIA vision of the world is a bunch of dumb fuck cattle. That's what they want. They want dumb fuck cattle. That's Bill Gates wants dumb fuck cattle. He gets his jollies out of herding dumb fuck cattle. I don't know. He gets his jollies out of dumb fuck cattle. That's his. I talk with God all day. That nigger can fuck all the dumb fuck cattle he wants. Anyway, I talk with God. God is clever. Do something witty, Mr. God. Yeah, money. So, anyway, so they're trying to confuse people. Basically, I am disrupting because I have just-in-time compiling. Everybody else has interpreting. It's kind of weird because I've been talking since the 90s. I might have done it. I don't know. I could be the guilty party. But anyway, like they listened to me then and they listen to me now. But anyway, in any case, now it just, let's see. So I have a compiler. I wrote a compiler. I could show you a mini compiler in the demo lectures directory. There's a mini compiler. The lexical function simply converts numbers into a binary number. It converts operators. It removes comments and stuff. Then we're parsing operators, okay? And if the operator is the correct precedence, we go ahead and these are doing this is the multiply operator, the div operator, the add operator, subtract operator. So we can enter an expression 1 plus 2 plus 3 times 4 times 5. Now this is it's a stack machine, reverse Polish. So we push 1, we push 2, we push 3, we push 4, we pop 2 of them and multiply, we push the result, we pop 2 of them and add, push the result, we pop 2 of them, and so if we're looking here, we push 1, 2, 3, 4. I think we go to 4, then we pop 3 and 4 and multiply, push the result 12, then we pop 12 and 2, add, and we get 14. Then we push 5, then we multiply 14 and 5, and then we push the 14 and 5 is 70, and then we push the 70 and the 1, and then we pop 2 and add. So it's a reverse Polish. This is fucking compiling. This is not an interpreter. This is not bytecode. This is machine code right here, x86 machine code. You might ask yourself, what is x86 machine code? You get the architecture manual from Intel, and we can look at how to code an instruction. I wrote an assembler, I wrote a compiler. I did the fucking machine code by hand. I did the front end, the middle end, and the back end because I know I'm a black belt assembly programmer. So what we were just doing is adding 264-bit register memory and register. So Rex is the 48. There's the register. And what is this? Oh, that's the add in opcode. So it's a 01 with the register coded in 3 bits. This register is coded in 3 bits. So if it's RAX, it's 0. So it's going to be a 48, 0, and then the RM64, which is you look in a table in the for register memory, 16-bit, 32-bit. Okay, so if you want register memory, if we're doing AX to AX, then it's going to be 0, 0, 0 with 1, 1, and so it's C. So the final answer is going to be C0. So it's going to be 4801 C0 to add RAX, RAX. Oh, we're not doing RAX. Add RAX, RDX. Okay, 48. Okay, 03. That's the reverse. That's the reverse. You can do it one way or the other. There's 2 forms. The register first, memory second, memory first, register second. So we go to, okay, there's another one with 3. There's 3. Register first, memory second. And we want DX. So DX is a number, DX is 2. I think it's 2. DX is 2 on the, if you look in the tables, DX is a 2. You see that? It's not a 3, it's a 2. The order is different. A, C, D, B. So DX is a 2. So I don't remember if we want the 2 here, or it's a 2 and a 0, AX and DX. It's a 2 and a 0, and so A03 is the opcode, and 2 is DX, and the 0 is the is bits 4, 5, and 6 here. Anyway, so my compiler is a compiler. It's just in time, and Microsoft is trying to confuse people. If I say who, all the functions and symbols that are sitting in my, okay, we have okay, we're sitting here at the command line. Who, if you say who minus R, just we have I in the I is an environment variable. It's a compiler symbol. I equals 1 plus 2. So 3. Okay, so we can make a function U0. Let's, okay, I64 n I64 I for I equal 1 I less or equal to n I plus plus %d comma I. Okay, now we can say count to 10. Okay, we can say unassemble function count. Okay, it's in memory. It's kind of like a Commodore 64. You used to have basic programs in memory. Some people, the CIA brainwashes people so that they can't imagine any other mode of operating than Unix. You can have code at the command line. So the command line feeds into a C compiler. Okay, guess what? The first task is called Adam, as in Adam and Eve. And when he starts up, like autoexec.bat, he starts compiling this. He starts compiling StartOS. He starts compiling this. What does this have? It has some headers. Adam compiles some headers for the compiler and kernel. There's 2 modules, kernel and compiler. Those are ahead of time. Nothing else needs to be ahead of time. kernel bin and compiler bin. So we have some headers for those, and then we start compiling code. During boot, there have been 50,000 lines of code have been compiled at this point. If I do a make all, when I compile the kernel and compiler, another 50,000. So 50,000 is ahead of time in the kernel and compiler. 50,000 is just in time during boot. If you want to see it boot, that's a normal boot. It can reboot that fast. I'll do a cold boot. If I do reboot my bootloader, that's a normal boot. Now we're going to modify the startup to echo to the screen all the code that it's compiling. So as it compiles this make, that make, let's go look at that make. The make atom is a bunch of includes. Okay, so when we boot, we're going to do a bunch of includes. We're going to include the headers, and so right now it's including the headers, and then it's starting to compile. This is putting code in Atom's space. Okay, you know how when we compiled a function, it put it in our space. Atom has this in his symbol table. I'm going to undo that because I don't want it. I'm getting rid of that's weird. I'm getting rid of okay, I got rid of that. So at this point, the Atom task has all those symbols in his table, and we inherit our parent symbols. So if I say who, this is all my parent symbols. So I never need to do an include file. You don't have there is no path, because the command line feeds into a C compiler, and you don't if I typed test in Unix, that would say execute, but that's not what this does. This feeds into a C compiler. To execute it, I have to say #include. Okay, does that make sense? Doesn't that make sense? I can do a shortcut. I go there and then hit include. But anyway, so I say #include test.cpp.z. Okay, I'm pretty sure. Did I screw something up in here? No. Okay. Include undefined identifier. We have a oh, I have garbage in there. Okay. So now we're executing at the command line. So if we hit Control-Alt-C, now if we say who, now I don't want my parent symbols, so I say -R. That's not recurse. So we have main, which is here. We have numwords, which is here. These are environment variable scope, but they can be functions, they can be global variables, they can be #defines. Okay, so what else was the evil CIA confusing people on? They brainwash people so that they cannot imagine any other way of operating a computer. We all grew up with the Commodore 64, which you typed in, and if you put a line number, it put it into memory as a basic program. If you did a statement, it executed immediately. Somebody said, well, anyway, somebody said it's like a Commodore with the C language instead of BASIC. There are differences in the syntax. Be aware. the shift operator is a higher precedence, and you need an address for a function address. You need an ampersand. Anyway, who was talking? So let's go ahead and do a little more tongues. So we can pick. Let's. Why don't we take the. Oh well. What do you think, Mr. God? Do you like the Commodore 64? We can hit F5. Okay, so let's call it a day. Okay, so let's see if there's any comments in the stream here.
Let's see if there's any comments.
There's not an off by one. The block numbers start at 2 and the it's not an off by one.
There's not an off by one.
Unless you
The block numbers start at 2 and the
boot record. Oh no, it's not a. I want absolute blocks. I don't want relative blocks. One of my goals is to eliminate. Let's just see what he says. So. One of my highest goals is eliminating whole concepts like mem BIOS rep. So this is physical memory reported by the BIOS, and normally you map this to virtual memory, or virtual memory maps to physical memory, and but we don't have a concept of physical and virtual. There's only one sort of memory address, and that's physical. Everything is physical. So in my file system, in the FAT file system, there's a concept of clusters and a concept of blocks, and I want to simplify. If I can eliminate a whole concept, that makes me happy. I like to get rid of abstraction. If I can get rid of abstraction, that makes me happy. Okay, so there's a FAT table in. Okay, let's do a drive report. Okay, so this is a drive report. The colors make it confusing. Okay, so the Red Sea goes from block 0 to block whatever. This is a RAM disk, Red Sea RAM disk. Then I have FAT32 hard disk, FAT32 hard disk. So let's go look at the RAM, at the Red Sea RAM disk. You know, I could format my partition. Okay, well anyway, so drive B. Let me say directory star. This is a full directory, and we have no files. Let's do Control D. I'm going to copy my home directory over to my RAM disk. Okay, so now I do a directory. I have a home directory. This is on the RAM. This is on the RAM disk. True reports clusters, except they're blocks. So with FAT32, you don't allocate blocks, you allocate like 20 blocks at a time. So with FAT32, the numbering for the cluster starts at the data area of your. I want blocks, not cluster. I want blocks, not clusters. So 102 is okay. So what are we using? Okay. There's a allocation bitmap. If we look at how big our drive is, well, anyway, let's do this. Class rep, and then I say letter to block device. Is this gonna work? Letter to block device B. Okay. So this is the block device, and it says the minimum block is 0, the maximum block. So there's a low-level protection that keeps you from going outside of your partition. So it's pretty safe. If you operate on one partition, it probably won't accidentally kill another one on your hard disk. It'll stay in the partition. That's a pretty low-level check. Let's go ahead and look at drive. I was using the word partition and drive, but I got rid of the word partition, and now I just call it drive. So I just for terminology, if you can eliminate a term, they used to say partition or they used to say drive. Now all I say is drive. So the data area starts at 101. That means we have 100 blocks of allocation bitmap. So somebody says my numbering is off. So according to my, okay, so the first, the size is 100,001. That's kind of weird. There's a reason. I could explain it, but it's pretty hard to explain. You want to know why that is? Okay, I can tell you why that is. When you allocate malloc, let's say let's say if we allocate 100 bytes, then if we say M size B, we allocated 104 bytes. That's the user area. The system area is 120 bytes for the overhead, M size 2. Now if we allocate 1,000, let's say like this. Okay, now at this point we I think we switched to a power of 2 plus 1 block. Well, I'll just tell you that. Once you start getting up here, it's a power of 2 plus. Why do I do 2 blocks? I don't know why I do 2 blocks. Okay, you have some overhead, as you know. When you do an allocation, you have some overhead. So here's what I didn't want. Why did I do that? I did a dumb example. 0x. Okay, let's say you were allocating 2. What is that? 2 meg or something. Now it could do 4, which is the next power of 2, because you need some for your overhead. But what it does instead is a power of 2 plus, I do plus 2 blocks. I don't know why I do 2. Maybe I should change that. I think it would. So I do, so that's where, So that overhead would I should do one block. I'm sorry, but I should do one block. So the reason we have an off by 1 is the size works out. There's an extra block, and therefore I think it's part of the mallet. We could change that, and then it would. I'm nervous. Maybe should I change it? Is it correct? I hate making changes if it's going to screw something up. I don't think it's going to screw. I think it's correct. I don't think I was careful. So I'm going to go to the kernel and change it. Don't tell anybody. I'm just kidding. Okay. So I don't know if I'm just gonna put it on the next release. So we go to malloc, and we want to look for oh, the slop. There's a pound define for this. It's not slop, is it? No, it's not slop. Okay, so we go free hash memfree page, somewhere around here. Extra hash pages 2. It is common to malloc exact powers of 2. There is some overhead. We add 2, so a request is not rounded up to the next power of 2. Now, the reason I might have done this is because maybe you are creating a block pool structure. In the block pool structure, I don't know. Nobody would do that. I'm nervous. What's going to happen? We might suddenly have extra memory usage. Okay, let's be careful. Here's what we'll do. We will do a cold boot, and we will record. I'm going to write down the memory D5682800. Okay, let's reboot it again just to make sure. D5682800. Okay, now I'm going to go to memx hash page. Now I'm going to let's try it. Okay, now I'm going to compile I'm going to do a make all. This compiles my kernel and my compiler. Now I don't have object files. This is directly compiling everything. Does that blow your mind? It's only 20,000 lines. Now I'm going to reboot, and our memory says, oh shit. Okay, so I was good to be cautious. It says CCB6A400. So I don't know what happened. That's bad. So in other words, it got kicked up into another power of 2. So I should investigate that. You know what I'm going to do? I'm going to put it on my to-do list. To do hard or not worth doing. To do meh. To do. I think we'll put it on my actual to-do. I might actually do that someday. So mem. Okay, what do we call that symbol? Mem. Okay. So I'm going to make a note. Control L. Link. Man page. Okay, So apparently, oh, did I change it? Let's go back. Okay, now we're back to D5682 2E00. Okay, I don't know why. Okay, so let's do it again. D5683. Oh, that's not good at all. Why is that changing so much? Son of a bitch. There's a D5682E00. So I don't know. That's kind of bad, isn't it? So let's go ahead and let's look at. So I think I figured out what that was. What else we have here? Second errors only occurs when the volume is an exact multiple. Yeah. Here's what it does. Here's what it does. Let me explain. Okay, so malloc doesn't give you. Malloc sometimes gives you more than you ask for. If you say star b equals malloc 40, let's say you do this. Let's say 43,000. Okay. Now it has to use a power of 2. So if we say M size, any malloc symbol you can use M size and heap control. So what did it do? It did 80,000 plus those 2 pages. So it gave you more than you asked for because it's dealing with powers of 2. Now when you allocate a RAM disk, it disobeys your order, and whatever it got, it uses the full range. Now this, I might have to change this because sometimes you actually want it small. When you're making an ISO file that's an image, you want an exact size. You don't want to round it up. So I can change this. It makes me, well, it kind of sucks, frankly. Doesn't that kind of suck if I change it and then it wastes? It's kind of it's a nice feature, isn't it? But maybe it's more important to if you make an ISO file. So if you make an ISO partition, if you make a file that you want to transfer onto a CD-ROM, you want it exact. You don't want the full range. That affects the way it's formatted and stuff. Anyway, what do you think about explosion of compile times caused by include? Now, if it, I don't know what he's talking about. I can. Yeah, we're only doing 9660. We're not doing the other ones. Actually, we're not doing. I already have 9660. We're going to replace 9660 with Red Sea, so that we only have one file system. We're just going to. It doesn't need an allocation bitmap for a CD-ROM, but we're gonna force them to stick it on there. Do you think having a dynamic language? No, I have a just-in-time compiler. No, we're not doing that. You know, there's a lot of things you might want, but this is limited. A lot of people like to spread FUD, confusion. I don't appreciate you mentioning dynamic, because that's likely to get people confused. That's what a wicked CIA nigger does, is he goes around, oh, like, roughly speaking, you know, there's the Shakespeare play of Julius Caesar. He says, I come to praise Caesar, not to bury him. And in fact, he's doing the opposite. So we get these CIA niggers who think they're being clever. Fuck you. Anyway, so, okay.